Hi, I'm here to teach you logarithms today. So let's start. Now, if I have something like exponential form like this, okay, a power m is equal to n. Standard form of writing in logarithm is log m log n to the base a. Okay, this I am bringing this side, and this must be this side. Okay, when I write in logarithmic function, log n to the base a, log of n to the base a, okay, is equal to m. That's it. I only interchange the positions of the power. Okay. Let us take an example. Now, for example, if I have 3 cube is 27. Okay. I can represent this in logarithmic function as log 27. I am bringing this side to the power to the base 3. Keep in your mind that base is always down. Okay, this base never changes. It's always down. It doesn't change any position. That's it. Only these both will be changed when you write in logarithmic function. Okay. Let us solve some more examples like this. If I have 4 power minus 2 is equal to y. Okay, if I have like this something, I can write this in logarithmic function as log y to the base 4. I said you already that base will be same, is equal to minus 2. That's it. Sometimes they may ask us to find the value of x. Now if I have something like, if I have like this, log x to the base 5 is equal to 2. I can represent this as, first I'll have the base same 5. This will come this side and this variable will come this side. So I get 5 square is equal to x and x is equal to 25. That's it. Now if I have like this, log x like this, log 25 to the base x is equal to 2. If I have like this and they are asking the value of x, what would I do? Base will be the same, this will come this side and this goes this side, right? So this comes here and this 25 goes that side. Now what will be x? X will be root of 25, which is 5, plus or minus 5, but you take less here. Okay, that's it. Let us learn some basic properties here. Now first, if I have, okay, log, now if I have log 1 to the base a, that will always be equal to 0, because now, okay, if I convert this in normal thing, like if I have the base will be same, this 0 comes here, this 1 goes here, right? So power 0 equals to 1, right? This is the standard format. In exponential form you have, in exponents and powers you have learned, right? Anything power 0 is 1. When I convert this in logarithmic function, I get log, base will be the same, this 1 comes here and 0 goes outside. So only we got this as one rule. Okay. And the second rule is log a power a is equal to 1. Okay. So first I am converting into exponential form. That is, this a will come here, this powers will be changing. So this comes here, this goes here, right? Equals to a. That's it. So when I convert again into logarithmic function, what happens? Log a will be as it is. This comes here, this goes here, equals to 1. This is other rule. The next rule is when I have log a power x. Sorry, you must pronounce it as log x to the base a. Okay, is equal to log y to the base a. Here these both are same, right? So I get x is equal to y. Bases are same, right? As you learnt in exponents and powers. So these all are some kind of rules. Now let us solve one example. Let us now go with an example. Now they are asking us to convert log 0.04 to the base 5 is equal to x. Okay, they are asking us to find this x. So what will I do first? First I will change the power. So I will make this base is same always. So only power changes. This comes here, this goes here. So I am putting here up is equal to. Now 5 power x is equal to 4 by 100, right, in decimal form. So I get, when I solve this, I get 1 by 25. Okay, 5 power x is equal to 1 by 25. How can I write this 1 by 25 as? I can write it as 5 power minus 2, right? 1 by 5 square, then I get 5 power minus 2. So base I made it same, x is equal to minus 2. It's time for us to learn some more properties which are basic. Okay. Now if I have log a, log mn to the base a, I am having. I can write this as log m to the base a plus log n to the base a. Okay. As you have learnt in exponents and powers only, it is very easy. If I have log m by n to the base a, I can write this as log m to the base a minus log n to the base a, right? As you write in exponents and powers only. Then if we have log n base m, then again a. Okay, if I have like this, then what will I do is I will bring this power this side. Okay, I will bring this power front side. So I get n log m to the base a. It is easy only. Most of them are confused with this base changing formula. It is easy. Now look, if I have log m to the base a, okay, I don't want this a, I want some other variable. I don't want this a. Then I have to change the base, right? So for changing the base, what should I do is, first, okay, you write this m, okay, in numerator, and down you write this a in denominator, okay, and I can assign, if I want the base as x, okay, then I take base here also as x. Here x, because anyway it's going to cut, so I can take any variable which I want, okay. So first I do this one, then I will bring this side, okay, I'm bringing this denominator this side. So when I bring this side, what happens is log m to the base a into log a to the base x, right, when this comes this side, okay. So what happens now is, we can cancel this a and a out, okay. Just for now I get log x, which is in base here, and log m to the base x, okay. This is what I get, and I have changed the base, see here and here, right, I have changed. That's it. This is only the base changing formula. I will teach you another formula which is reciprocal, and it's very easy. See, now if I have log a to the base b, okay, it is very easy, and if I want to reciprocate it, I write 1 by log b to the base a, only the base and the power, they both alone interchanged, okay. That's it. This is only reciprocal formula. Now what if I have a, okay, power log x to the base a, if I have like this, what shall I write? It becomes x, okay, because I can say you like, I'll bring this first this side, right, this x this side. What happens? X log a to the base a. A to the base a is what? 1, right? That becomes x into 1, which I write x. This is another formula. And if I have, okay, log a to the base b, and it's multiplied with log b to the base a, answer is 1. Okay, I cancel these both, and I get 1. That's it. Suppose I have this question like log x to the base 2 is equal to a. This is only given, okay. And here log y to the base 3 is equal to a, they have given. And they are asking you to find this 12 power 2a minus 1. Okay, how will you find this? First you take this, okay, this equation, that is log x to the base 2 is equal to a. Okay, first I will convert this into exponential form. Okay, so what happens? Base remains same. This comes up here, this moves here, right? So I got x value 2 power a. Okay, this is one equation. And the next is this one. Okay, for this what I do is log y to the base 3 is equal to a. This also same only. So what happens? Base same, this comes here and y goes that side. So y and x, okay, I have these two values. Now first you have to try to simplify this, okay. So I am taking this 12, 2a minus 1, okay. This is the first thing. Now I can write this 12 as 2 square into 3, right? Yes. So I can write separately like this now. 2 square into 2a minus 1 into 3 2a minus 1. I will get this right when I multiply separately. Now 2 power 4a minus 2 into 3 power 2a minus 1 I get. Now I can still simplify this like 2 power 4a by 2 or into 2 power minus 2, okay, into 3 power 2a by 3. I get like this. Now I can take this 2 power a power 4, okay, 4a anyway, okay, I am simplifying like this, 3a power 2 by 2 square, okay, 2 square is 4 into 3. Now I can write this as this 2 power a, I already found the value that 2 power a is x and 3 power a is y. So I am substituting it. X power 4 into 3a I found as y. Y square by 12. This will be the answer. That's it. Now let us solve another example. Okay. So they have given express log a square c by root b to the base 10 in terms of log a to the base 10, log b to the base 10 and log c to the base 10. Okay. So first of all, what will I do is I have to simplify this, okay, to get this value. So first I am going to start log a square c to the base 10, okay. So this is in division form. What did I say you before? Using this, okay, I can write, I said you that log mn to the base a, okay, I can write this as log m to the base a plus log n to the base a. Like that, if I have log m divided by n to the base a, I can write that as log m to the base a minus log n to the base a, right? Same thing I am using here, minus log root b to the base 10, okay. So why you write the reason, okay, it will be not confusing, so that because log m by n to the base a is equal to log m to the base a minus log n to the base a. Okay. Now second step is you can still make this, okay, this is in multiplication, right? So log a square to the base 10 plus log c to the base 10 minus log root b to the base 10. Why did I do this? Because log m into n to the base a is equal to log m to the base a plus log n to the base a. Okay. Now look here. Now using another formula, that is, okay, I have this 2 here, right? So we saw a formula. Log x to the base y, okay, that is log x square to the base property, no? Log x square to the base y, okay, that 2 will come front side, okay, that square. So same like that you have to do here also. This will come this side. So I get 2 log a to the base 10 plus log c to the base 10 minus this b is in root, right? So root value is what? This is in square root. Square root value is 1 by 2, no? So I write log 1 by 2 will come this side, okay, b to the base 10, okay, 1 by 2 I had brought this side, okay, because log x square by y, okay, that is equal to 2 log x to the base y, right? Yeah. Now I can write still, okay, but we have done it because they have, see the question they have asked. They have asked us to express, okay, they have asked us to express in terms of log 10, log a to the base 10, log b to the base 10 and log c to the base 10. Okay, we got it. Log a to the base 10, log c to the base 10, log b to the base 10. That's it. So sum is over. Now take this question, okay. First I am having here x and y. I have to solve this. Here I don't have any variable, right? So I am taking this equation and this number, okay. First log x plus y by log 2 is equal to minus 2, okay. Now I will take this side, right? So what do I get? Log x plus y is equal to minus 2 log. Now this is here, I can take to the power, right? Because from the power only it comes front, okay. Base is 10. See, one more thing I have to say is, if there is a log, okay, you take like anything, okay, here the other property is, if I have log a, okay, simply I don't have any base, then I have to take the base as log a to the base 10, okay, only 10. If there is no base, only you have to take as base as 10, okay. In this sum you don't have to take any base and all, because they haven't given the base in the question, see. So no use of the base, so no need. Let's not confuse. Now here I got this equation, right? First, then log x plus y is equal to log 2 power minus 2. Sorry, log minus 2 to the base 2, okay. You have to pronounce it like that only. So what did I do first? I am taking this and this this and these both, okay. Then I am writing in the left hand side, I am writing this equation, and in right hand side I am putting that number. Then I am taking this to the right hand side, okay. This remains as it is, okay. This goes into multiplication and it becomes like this. Then from here I am taking this minus 2 to the power, okay, and I am writing like this. Then log x plus y is equal to log 1 by 4, okay, because 2 power minus 2 is 1 by 4. Now log and log can be cancelled. I get x plus y is equal to 1 by 4, okay. This is my first equation. Now what about my second equation? For that, okay, I have to take x minus y. Okay, this is there. This is the question. Log x minus y by log 3. Okay, that is also equal to minus 2. Okay. These both I am taking now. Okay. Now again I am taking this side. What happens? Log x minus y is equal to minus 2 log 3. Log x minus y is equal to log 3 power minus 2, which is 1 by 9, right? So x minus y equals to 1 by 9. This is my equation 2. So when I solve these, okay, adding equation 1 and 2, x plus y, x minus y. When I add these both using substitution method, okay, that will be easy. So this is equation 1, this is equation 2, right? So using substitution method, I get x is equal to 1 by 4 minus y. Then substitute this in equation 2. 1 by 4 minus y is equal to 1 by 9. 1 by 4 minus 2y is equal to 1 by 9. Minus 2y is equal to 4 minus 9 by 36, which I get y is equal to minus 5 by 36 into 1 by minus 2, 5 by 72. Okay, minus and minus will be cancelled. So I got the y value as I got the y value as 5 by 72. Okay, substitute in equation 1. What did we take that time? X is equal to 1 by 4 minus y. So x is equal to 1 by 4 minus 5 by 72. So when I take the LCM, okay, using L method, I get 72 is the LCM. Okay. Now x is equal to 1 by 4 minus 5 by 72. X is equal to 18 minus 5 by 72. Okay. X is equal to 13 by 72. That's it. So y value is what? What did we find? 5 by 72. That's it. Okay, time for us to recall once. Okay, all the formulas would have been collapsed. So first of all, I said you in logarithms a per m is equal to b. Okay, if it's like this, first what do I do to convert logarithmic form is log, base will be as it is. Okay, this will come to the power. Log b to the base a equals to m. Okay, this is my first thing. I said you first rule. Secondly, if there is log 1 to the base a, the answer always will be 0 because I explained you already. And next is if log a to the base a is there, then the answer is always 1. Okay. Then third point is if log m into n to the base a, then what will be the answer? Log n to the base a. Fourthly, log m by n to the base a, then log m by base a minus log n to the base a. Then fifthly, this is only base changing formula. Log a, log m to the base a is there. Then how will I change? First I'll write that in numerator and denominator. Okay, base, power and base. And I will put which is my favorite base, I will put that. Okay. Then I will take this side and multiply. If I multiply, I will get log m to the base x. Okay. Then sixthly, we get, if that is log m to the base b. Okay. I can write this as log m to the base a into log a to the base m. Sorry, I can write this as log a to the base b. Okay, because I have changed this into b. If I want, this is also base changing only, this only. Okay, if I have like this, and if I want this one, I can write like this, because these both will get cut off and I get it. Okay. Then next I have, if I have log a to the base b into log b to the base a, answer will be 1. Okay, I will cut these both and I get 1. Then next is reciprocal formula, okay, which is, if I have log b to the base a, I can write this as 1 by log a to the base b. Okay. And next is, last is a to the log x to the base x, a. Okay, then I get answer is x. Okay, I said you why it comes already. So thank you for watching this video. Hope you understood everything about logarithms. Bye.